Well, I was looking to make things improved upon and possibly more realistic, and I don't know about realistic, but it is um, a powerful improvement. It's explosive, unfortunately. It's not regulatable very well anymore. And wouldn't you know it, it's because I added in another capacitor. So I'll show you in a second where I added it. This is the output, and I can't get it to be anything other than in the range of 1e to the 60, more or less, slightly less, more or less. So these are spikes that are AC, slightly going down in the negative, then going slightly up in the positive. And I've also reduced the time it takes to get there. So it's no longer 10 seconds, it's a little over 10 milliseconds. So it's vastly reduced amount of time that it reaches humongous levels of explosive force. So this is the voltage on the inductor. Because I'm figuring the inductor, they might have put a few turns of wire around the inductor. This is a very large inductor, by the way, 10 henries, well, moderately large, in order to transfer the force to the motor. That's what I'm guessing. The Amman brothers, when they had the drum in front of their car, they probably had a very large coil in that drum. And the one thing that nagged me, that they said they had a mineral that was included in there: iron, wire, and a mineral. And I kept wondering, what mineral could it be? Could it be liquid mercury surrounding the coil? That has interesting possibilities, maybe. But then, when I put a capacitor in parallel with that coil, everything changed. And so the mineral may be the dielectrical material of that capacitor, whatever they were happening to use as their capacitor. Maybe the mineral was mica, maybe it was something else. But 100 years ago, what did they have available for making capacitors? And you didn't use anything high-tech like Tesla would use, a vacuum tube capacitor. So maybe they used some other kind of capacitor. Now, I had to use well, I'm getting ahead of myself. I had to use a capacitor of very high value to get these results, or any results. Just to get overunity, I had no choice but to get explosive overunity, unfortunately. I can't regulate it once I put that in there. But it certainly increases the potency of this thing, because I couldn't reduce it below 10 seconds. Now I can reduce it to 10.4 milliseconds, which is very good. When you're trying to run a motor, you want power fast. So that's the voltage on the inductor, and this is the amperage. So likewise, it spikes, but now we got triangles along with much more narrower spikes, and this is the amperage on the and that was the other thing, the most important thing. Prior to adding this capacitor that I'll show you in a minute in parallel with the inductor, all this device could do is produce a lot of voltage. It couldn't produce current. And I kept wondering, well, how can I get current to enter into this and not kill the overunity? And this is how, by putting a capacitor in parallel with the inductor. So they probably had a capacitor somewhere inside that drum, connected in parallel to the two terminals of the coil of the coil inside that drum. And so what happens is, instead of a vastly reduced current, you get to raise the current to 1% of the voltage in terms of units. So the units of current, amperes, and the units of volts, or voltage, volts. So the amperes is 1% of the voltage, and that's not bad. It's not great, but it's a lot better than what it was before. And then it makes the whole thing explosive because of the addition of the capacitor. Capacitors tend to be explosive. So now this is the RMS current of the inductor, and you see it stepwise increases to the right. It's still in the range of, what is this, 4, 6, what is that? Yeah, between 6 and 8 e to the 56 power of 10. That's a lot of power. You can just imagine, the RMS is like 1 e to the 111 or something, you know, it's really huge. Okay, now this is the circuit. Did I have another one? Oh yes, this was the voltage, the RMS voltage. So again, it's stepping up, and it's now to the 1e to the 57. So one more power of 10. Was that one more power of 10? 6 to the 56. Oh, it's less than 1%. Wait a minute. The RMS ends at around 7e to the 56. While the RMS here, the voltage ends at 1 point, maybe 4e to the 57. So 57 at 56, and 14 is 2. That's 2 to 1. Oh my God, the RMS, oh wow, this is fantastic. The RMS voltage versus the RMS amperage is 2 to 1. I had to change that on the schematic. Okay, so this is the schematic, and the only thing I added was this capacitor in parallel with the inductor, probably tucked away, hidden inside the steel drum. And I got rid of the ring around this lone capacitor because it's not needed anymore. These has a center spine, which is the center of their sphere. So now we have only one bronze sphere instead of two. So this is the improvement on the Amman brothers. We don't need two spheres on either end. We just need one sphere on one end and a ground on the other, and we're back to a Tesla coil. Oh God, don't you just love it? But now we've got this, but that's from the prior version. That's carried over from the prior version. The only change that I just didn't realize it till now, that I can get rid of the sphere on the right hand side. The only change is putting this capacitor of 7,000 farads in parallel with the 10 Henry coil. And that's when we get these explosive results in which the amperage is raised so high, it's now 1/10 in units of amperes to units of voltage. And that's huge. So now I have all the watts, we got the power we need. Before, all I had was voltage, and now I got power. And that's important. I don't know how to regulate it, but, well, no, here you go. When you transfer the power from this coil to the motor coil, you reduce the mutual coupling between the two coils. The pickup coil, the secondary, picking up the power from this coil and sending it over to the motor. The pickup coil, let's say it's 2 turns of wire around this, or whatever it happens to be, there has to be a spacing to reduce the mutual coupling. I would imagine that might do the trick. The other possibility is maybe I should start putting resistors in here. Now there's already series resistance in this coil, and there's equivalent series resistance in all of the capacitors. So it's not like I have to add resistors. And I don't know if that'll do anything. Sometimes resistors makes things worse. Actually, no. If it may make it worse in the sense of increasing the voltage and thus increase the current, maybe, depending on where I put it. If I put the resistor along the center spine, several of them, I guess, that would probably be the place to put it, I'm guessing, but I could be wrong. Because if I put it anywhere else, if I put it on the outside of this sphere, or on the left side of the inductor, it's going to reduce the current in the inductor, and I don't want to do that. If I put the resistor to the left of C14, that's a possibility, but not on the right, because then it puts it on the right of the inductor. The other possibility, this is covering this value, this node voltage. Oh, let's get rid of it then. Oh no, I can't. This is a photograph. This is a screenshot. There's a capacitor here of 100 farads. That's the other thing I was able to raise the capacitance of the C15. Now I no longer call it a throttle because I can't throttle this anymore. I raised it to 100 farads from 18 farads. And that's good because that makes it more buildable, more likely to be built, because it's much easier. You just get a piece of glass, basically, You know, like glass facing. What I like to do is go into the hardware store and get plate glass for a picture frame to put a picture of somebody. You know, 5x7 picture. It's got a 5x7 piece of glass. That's probably the correct ballpark of the capacitance for that dielectrical geometry. Then you just electroplate aluminum, let's say, on both sides, and now you got yourself a capacitor. Let's see. So what was I going to cover? Yeah, I mean, if you can't get a capacitor that low value of 100 farads, excuse me, 100 femtofarads. Oh yeah, I reduced the number of 100 picofarad capacitors. I think I converted 2 of them into 10 picofarad capacitors. I couldn't convert any more without collapsing the overunity. So now there's only 3 capacitors that are 100 picofarads. All the others are 10 picofarads in parallel with each other, but in a radial design surrounding the center spine. So I'm not sure how to regulate this. I think I'm going to have to work on it some more to see if I can. Maybe, you know, putting resistors somewhere might do it. I'm afraid to put diodes anywhere. I'm not sure what that'll do. Now the Amman brothers was running a DC system, I think. I'm assuming. I don't know. We don't know. But I'm assuming that's the case because the power on their little vehicle was not so great. Well, the power on the Pierce Arrow, and we know from the story of the Pierce Arrow Tesla in 1931, he used an AC motor. So I'm guessing this thing didn't have a whole lot of power, and it was probably a DC motor. So that means I got to put a diode in here to stop the oscillations. Where would I put it? Would I put it adjacent to this capacitor? Probably. Or would I put it adjacent to the inductor? Which means I could put it anywhere along here as well. Well, not necessarily. It does matter. So if I put it in series with this capacitor, that's one possibility. I could put it in series with all of these capacitors, another possibility. I could put it in this area here between C15 and C14, or in this area over here between L1 and C14. Or I could put it to the left of L1 before it hits these. So there are all kinds of possibilities of where I could put it. And then maybe it would be regulatable at that point. Usually diodes don't do that. They either kill the overunity or they explode it even further. It's one extreme or the other. I'll have to try that though. Now in those days, the only way you could make a diode that I know of is to use borax in a solution. And you have to put 2 electrodes, you break the circuit and you put the 2 electrodes where you broke the circuit into the beaker of borax, and that creates a diode. So it's possible, Tesla probably would have used a vacuum tube of some sort to create a diode effect, but the Amman brothers, they said there was a mineral in there. So I'm wondering, okay, what's the mineral? Maybe it's boron. Maybe they had a borax-oriented diode, except I'm still not clear where I would put the diode, if it indeed it had a diode. So I got some more work to do on this, I think. Okay.